Hello, good morning. Yesterday, some problem we facing because of the app issue. I called to this app and I mailed them, and that one resolved. Because live class is very important for us. People are joining or not joining, because once we have to take the live class will be kept as it is in our app. If we finish the mathematical methods of physics, how wondrous is there. You have to see the mathematical methods of physics, each and every topic I told in the mathematical methods of physics. Now I am starting in the classical mechanics, special theory of relativity I am teaching. This is the 13th class. Maybe 2-3 classes I have to take, and I will wind up this class special theory of relativity, and again I have to enter into the Newtonian mechanics and Lagrangian mechanics and Hamiltonian mechanics and Jacobi Hamiltonian mechanics. So like that I have to enter into that. But once you have to see how perfectly I am teaching all the concepts, so very important. I am taking so much of time, because why I have to teach like this? This is my own institute, I am teaching like this. So maybe I have to kept the target up to the February. I have to finish this classical mechanics, don't worry. Again after finishing these two papers, I have to take the fast, and I will finish the rest of the papers also. Rest of the papers, total 9 papers we have. Within the 9 papers this year, 9 papers I want to finish. One paper we finished, mathematical methods of physics. Now we are in the second paper, that is the classical mechanics. Maybe we are in the starting only, no. So this year 2025, all 12 months I have to take the classes, CSIR classes. I want to finish the whole syllabus for purpose of you only. Please utilize the chance. You have to tell to your friends also. Like this, you know where you will get it. Maybe you have to go to the any competitive coaching center, you have to take. Nowhere you have to get such type of information, such type of theory oriented questions also no one can teach to you. Maybe if you have to join, you have to join in winner UV, so they will teach you in problematic orientation. If you have to join in other institutes, they will cover only half of the syllabus, but not like this in our app. That our app is only to finish the syllabus perfectly, point to point and word to word and formula to formula. So that is very important. Please concentrate on this, and you have to tell to your friends also who are using this app. So those people will tell to your friends and inform to your friends. This app is very essential and very essential to learn the physics concept. Clear? Now we will see relativistic kinetic energy. Relativistic kinetic energy, how we have to write. In previous classes we discussed about the Einstein's relativistic equation. From this Einstein relativistic mass energy equivalence, we discussed one kinetic energy equation. What is that kinetic energy equation? The kinetic energy is equal to C square into m minus m naught V square. C square into m minus m naught. This is the kinetic energy equation from the Einstein's mass and energy equivalence equation. But you know the m is a mass in relativity. M is equal to gamma into m naught. M is equal to gamma into m naught. Since gamma is equal to what it is a Lorentz factor, that is 1 by square root of 1 minus v square by c square. This is the gamma value. Now you have to substitute there. Therefore kinetic energy is equal to which one we have to get? C square into gamma into m naught minus m naught we are getting. Gamma into m naught minus m naught we are getting. Clear? So therefore m naught you have to take outside. Kinetic energy is equal to gamma into m naught into c square into m naught gamma minus 1, c square into m naught gamma minus 1. This is the kinetic energy principle under the relativistic constant, that is 1 by square root of 1 minus v square by c square. Now I have to substitute this. Once you have to see kinetic energy is equal to m naught c square into gamma. I am substituting 1 by square root of 1 minus v square by c square minus 1. This is the kinetic energy of a relativistic equation. Kinetic energy of a relativistic equation. So this expression we call it as what expression is it? This is the expression represents the relativistic kinetic energy of the body. This is the expression represent the, this is the expression, right, represent, this is the expression represents the whom? Relativistic kinetic energy of the body. Relativistic kinetic energy of the body. Kinetic energy of the body. This is the expression represents relativistic kinetic energy of the body. Represents the relativistic kinetic energy of the body. Clear? So please remember. Now we have to discuss about various cases in this kinetic energy, relativistic kinetic energy. First we have to see the case number 1. What is our expression? Once we have to see in the case number 1 we have to take so velocity is less than, for small velocities if you have to consider, v is less than c. V is less than c means for small velocity of the bodies, for small velocities you have to see, for small velocities how we have to write? V is less than c. But you know the kinetic energy is equal to m naught c square into 1 by square root of 1 minus v square by c square minus 1. 1 by square root of 1 minus v square by c square minus 1. But you know one thing, so what do you know? This is the factor. So that factor is equal to how we have to write? 1 by v square by c square all to the power of minus 1 by 2 we have to write. But you know the binomial expansion. What is the binomial expansion? Once you have to see 1 minus x whole to the power of minus n is equal to 1 plus n into x plus n into n plus 1 by 2 factorial into x square plus and so on is there. This is the binomial expansion from this formula. 1 minus x whole to the power of minus n is equal to 1 plus n into x plus n into n plus 1 by 2 factorial into x square plus and so on. Based on that principle, you have to write it is 1 plus n is equal to 1 by 2. 1 by 2 into x is equal to what it is? V square by c square. X is equal to v square by c square plus n is equal to 1 by 2. 1 by 2 plus 1 is divided by 2 factorial into x square is equal to, what is that? X square is equal to v square by c square whole square and so on it will come up to the second terms I have to consider. Now once you have to see v is less than c, that's why this term we are neglected. Therefore 1 minus v square by c square whole to the power of minus 1 by 2 is equal to 1 plus 1 by 2 into v square by c square. 1 plus 1 by 2 into v square by c square. Now this value have to substitute there. Therefore the kinetic energy is equal to m naught c square into 1 plus 1 by 2, 1 plus 1 by 2, what we have to write? 1 by 2, 1 plus 1 by 2 v square by c square minus 1. So minus 1 plus 1 get cancelled, c square also get cancelled. Therefore that kinetic energy is equal to how much we are getting? 1 by 2 m naught, 1 by 2 m naught v square we are getting. This is the kinetic energy of a particle when velocity for the smaller one. Now once you have to see this formula is equivalent to half mv square. of mv square is nothing but a classical kinetic energy, correct. So therefore for small velocities what we have to write, for small velocities the relativistic kinetic energy tends to the classical relation. For small velocities what we have to tell, the for small velocities the relativistic kinetic energy is equal to whom, the relativistic kinetic energy is equal to 1 by 2 m naught v square. This is the case number 1, clear, right. So this is very important. When v is less than c, we are going into the classical kinetic energy, classical kinetic energy. Now case number 2, what is our case number 2? When v is case number 2, you have to see, when v is equal to c you have to substitute, when v is equal to c you have to substitute, then what will happen you have to see. Our kinetic energy expression, when our kinetic energy expression is m naught c square into 1 by square root of 1 minus v square by c square minus 1 is there. This is our kinetic energy expression. Now you have to substitute here, when v is equal to c, m naught c square into 1 by square root of 1 minus v square by c square means c square by c square get cancelled, minus 1, correct. So 1 minus 1 is equal to 0. Now m naught c square into 1 by 0 minus 1 is there. 1 by 0 is equal to what it is, something by 0 is equal to infinite, infinite into minus 1 is equal to infinite. It tends to what will happen, kinetic energy is going to become as a infinite. So what it indicates, so therefore our kinetic energy is equivalent to infinite, matlab our kinetic energy is going to become as a equivalent to infinite, matlab if the particle could move the velocity of the light, v is equal to c means if the particle could move with the velocity of the light, if the particle could move with the velocity of the light, it would have possessed infinite kinetic energy. How much kinetic energy is there? It would possess the infinite kinetic energy we have here. So that is very important. If the particle could move the velocity of the light, it would have possessed infinite kinetic energy. This is very important one. You have to concentrate on this, clear. So this is the kinetic energy one. Now we are going to discuss about one more important area. So what is that area? Once you have to see relativistic kinetic energy and momentum relation. What is the relativistic kinetic energy and momentum relation? Once you have to see. Now you know the kinetic energy is equal to total energy minus rest mass energy, that is E naught you have to keep, total energy minus rest mass energy. So therefore the kinetic energy is equal to total energy, we know the formula. So what is the total energy? So total energy is equal to square root of p square c square plus m naught square c power 4. So p square c square plus m naught square c power 4 and m naught is equal to minus m naught c square, minus m naught c square. So therefore the kinetic energy is equal to, which one we have to take here, m naught square c square is there in the root. You have to take outside m naught c square, it will come. So m naught c square, so you have to take outside. So it will come here 1 plus, so 1 plus p square c square is divided by m naught square c power 4. P square c square is divided by m naught square c power 4 minus m naught c square, as it is I am writing. So therefore again you have to see the kinetic energy is equal to m naught c square into, here 1 c square get cancelled. Therefore you have to write here 1 plus P square is divided by m naught square C square minus m naught C square is there. M naught square C square minus m naught square. Therefore, what we have to write here? Kinetic energy is equal to, first you have to take the common m naught C square, you have to take the common. In both terms m naught C square is there. Now, you have to write here 1 plus P square is divided by m naught square C square whole to the power of 1 by 2 minus 1. This is the relation between whom? This is the relation between kinetic energy and momentum. This is the relation between whom? Kinetic energy and momentum. That's why this relation, this expression we call it as a relativistic kinetic energy. This expression we call it as a relation between relativistic kinetic energy, relativistic kinetic energy and momentum. Relativistic kinetic energy and momentum. This relation we call it as a relativistic kinetic energy and momentum. From this relation also we have to discuss about the special various cases. What are those cases? Once you have to see, those cases are, first you have to take the case number 1. What is our case number 1? Velocity is less than c, you have to take velocity is less than c. What is this meaning? For small velocities, what is the bodies are going with small velocities. So, velocities, small velocities, bodies are going. If the bodies are going with the small velocities, so what will happen? Once you have to see the term 1 plus P square by m naught square C square whole to the power of 1 by 2 is equal to the term 1 plus P square is divided by m naught square C square, which is approximately equal to what will happen by using the binomial expansion 1 plus P square by 2 m naught square C square it will come. P square by 2 m naught square C square it will come. So, therefore, from this what we have to write? You have to apply in the kinetic energy principle. Kinetic energy is equal to m naught C square into this term is equal to 1 plus P square is divided by 2 m naught square C square minus 1 is there. This plus 1 is minus 1 get cancelled. C square also get cancelled. Therefore, that kinetic energy will become P square by 2 m naught. So, P square is 1 m naught also get cancelled. P square by 2 m naught is coming. So, this is exactly equal to the relation between the classical kinetic energy and the momentum, correct? So, therefore, for small velocities, relativistic kinetic energy and momentum, relation tend to the classical relation. What is the classical relation? Kinetic energy is equal to P square by 2m. This is the classical relation. So, it is going to exactly equal to the classical relation. So, that is why when for a small bodies are going with small velocities, you will get the classical kinetic energy relation, that is kinetic energy is equal to P square by 2m. Clear? Now, we have to take so one more condition. Under the relativistic condition, what will happen? Once you have to see, under the relativistic condition, kinetic energy correction term we have to write. What is the kinetic energy? So, the kinetic energy is equal to already we know gamma into, so gamma into we have to write here. So, gamma into m naught minus, so m naught, gamma into m naught minus m naught. So, gamma into m naught minus m naught into c square, gamma into m naught minus m naught into c square. This is the relativistic kinetic energy expression. From this expression, what we have to write? In our previous first slide only we discussed this one.
m naught c square into gamma minus 1. Under the relativistic correction, gamma is equal to 1 by square root of 1 minus v square by c square. But you know one thing, so this one we have to arrange like this, 1 by v square by c square whole to the power of minus 1 by 2. By know the binomial expansion, by binomial expansion, which expansion you have to take? By the binomial expansion, 1 minus x whole to the power of minus n is equal to, now only I gave 1 plus n into x plus n into n plus 1 is divided by x square. So n into n plus 1 is divided by 2 factorial into x square plus n into n plus 1 into n plus 2 is divided by 3 factorial into x cube. So plus and so on it will come. Therefore, what we have to write? Gamma is equal to 1 minus v square by c square whole to the power of minus 1 by 2 is equal to 1 plus 1 by 2 into v square by c square plus 1 by 2 into 1 by 2 plus 1 into is divided by 2 factorial into v square by c square whole to the power of 4 plus 1 by 2 into 1 by 2 plus 1 into 1 by 2 plus 2 is divided by 3 factorial into v square by c square whole cube, plus and so on is there. Plus and which one we have to write? Plus and so on is there. This value how to substitute in this expression? What will happen once you have to see the relativistic kinetic energy? We are getting the relativistic kinetic energy. How we have to get the relativistic kinetic energy once you have to see? The relativistic kinetic energy is equal to m naught c square into gamma is equal to 1 minus v square by c square whole to the power of minus 1 by 2, minus 1 is there. This is the relativistic kinetic energy principle, correct? Now you have to substitute whatever the thing we discussed from the binomial expansion, 1 plus 1 by 2 into v square by c square plus 3 by 8 into v to the power of 4 is divided by c to the power of 4 and so on, minus 1 is there. Up to the 2 terms I have to take, right? 2 terms is enough for me. So minus 1 plus 1 get cancelled. Therefore, what we have to write? You have to take this outside the bracket, into the bracket you have to take 1 by 2 into v square by c square into m naught c square plus 3 by 8 into m naught c square into v to the power of 4 is divided by c to the power of 4. So which one will happen? So we have to get it as 1 by 2 into m naught v square plus 3 by 8 into 1 c square get cancelled, m naught into v to the power of 4 is divided by c square. Which one it is getting? V to the power of 4 is divided by c square. This is the kinetic energy. So this kinetic energy term, we are getting the 2 terms under the relativistic thing. One is a, this one is the classical kinetic energy. Which term it is? This term we call it as a classical kinetic energy. 1 by 2 of mv square is a classical kinetic energy. Classical kinetic energy. Now you have to see this second term is there. So what is this second term? This is the relativistic correction term. So that's why it is a relativistic kinetic energy. Which energy it is? Relativistic kinetic energy. Therefore, the kinetic energy is corrected under the relativistic. So what we have to write here? Once you have to see the kinetic energy under the relativistic mode is equal to, the relativistic kinetic energy is equal to, what we have to write here? 3 by 8 m naught into v to the power of 4 is divided by c square This is the relativistic kinetic energy, is very very important. This one we have to discuss in the electromagnetic theory also, in quantum mechanics also, in atomic molecular physics also, in statistical mechanics also we are discussing this one. This one is very very important. That kinetic energy, it consists of two terms. One is classical kinetic energy. The second term we are going to take it as a relativistic correction term. That term is a relativistic kinetic energy, that is equivalent to 3 by 8 m naught v to the power of 4 is divided by c square is there. That is the relativistic kinetic energy. So from this, if you have to take a graph, what will happen once you have to see? First you have to take under the relativistic kinetic energy correction, 1 by 2 m naught c square, 1 by 2 m naught c square plus 3 by 8 into m naught v to the power of 4 is divided by c square is there. Kinetic energy is equal to, which one we have to write? So 1 by 2 m naught c square plus 3 by 8 m naught c to the power v to the power of 4 by, so c square is there. So this one we have to take it as the kinetic energy of classical, the kinetic energy of classical. This term we are also discussed about the kinetic energy of the relativistic, which is equal to that kinetic energy is equal to. Now you have to take the graph between whom and whom you have to take. So between the kinetic energy you have to take it as in y axis. Kinetic energy you have to take on y axis, velocity you have to take it as x axis. So you will get the graph. So this is the relativistic kinetic energy you have to take, relativistic kinetic energy. Now you will take one more, this is the parabolic curve you have to get. So because 1 by 2 v square is there, no, not c square, this is the v square value, right? So 1 by 2, so 1 by 2 m naught v square is there, clear? So v square is there. This is the relativistic kinetic energy. This kinetic energy is a classical kinetic energy. So classical kinetic energy in parabola shape it is there. Which shape it is there? Parabolic curve. This is the relativistic curve it will come. So now once you have to see, this is the relativistic kinetic energy if you have to take. So now you have to take here, this one is a classical kinetic energy, right? So this is the graph between the velocity and relativistic kinetic energy. This is very very important. How the questions will get in our competitive examination once you have to see the questions. At what speed the total energy of the particle is n times of the rest mass energy. Now you have to see what they are asking, at what speed. At what speed means v is equal to how much? This is the first one. The total energy of the particle is, the total energy of the particle is n times of the rest mass energy. The total energy of the particle is n times of the rest mass energy. So therefore you have to see n times of the rest mass energy. So therefore what we have to write, n is equal to n into E naught. So but you know what you have to know, E is equal to gamma into E naught, you know, gamma into E naught, n into E naught. So E naught get cancelled. Therefore gamma is equal to, which one we have to write here, n. Just you have to simplify, 1 by square root of 1 minus v square by c square is equal to n. Just what we need, v square we need. So you have to take, just simplify, you have to take cross multiply, 1 by n is equal to square root of 1 minus v square by c square. 1 by n square is equal to 1 minus v square by c square. So this one you have to bring into this side. V square by c square is equal to 1 by n square. N square minus 1 is divided by n square is equal to v square by c square. Therefore v square is equal to n square minus 1 is divided by c square in n square into n square into c square you have to take, n square into c square. Therefore, v is equal to square root of n square minus 1 is divided by n into c. Which one we are getting? V is equal to square root of n square minus 1 is divided by n into c we are getting. This is very important application we have to get clear. Like this you have to do in your competitive examination. So, not only like that, one more question also you have to see, at what speed means here also same thing, velocity is equal to what they are asking, at what speed the kinetic energy of the particle is n times of the rest mass energy. The kinetic energy of the particle is n times of the kinetic energy of the particle is n times of the rest mass energy. But what is the kinetic energy? Now only we discussed about the kinetic energy. The kinetic energy is equal to gamma minus 1 into m naught c square. Gamma minus 1 into m naught c square, which is equal to n into E naught is equal to m naught c square. M naught c square, m naught c square get cancelled. Gamma minus 1 is equal to n. Gamma is equal to n plus 1. But gamma you know 1 by square root of 1 minus v square by c square is equal to n plus 1. Just simple, now just you have to simplify. 1 by n plus 1 is equal to 1 square root of 1 minus v square by c square. Therefore, you have to square on both sides. 1 by n plus 1 whole square is equal to 1 minus v square by c square. Therefore, v square by c square is equal to 1 by 1 plus n plus 1 whole square. So, therefore, v square by c square is equal to what we have to write? N plus 1 whole square minus 1 is divided by n plus 1 whole square. But what we need? We need the v square value. V square is equal to n plus 1 whole square minus 1 is divided by n plus 1 whole square into c square. So, therefore, v square is equal. V is equal to what we have to write? Square root of n plus 1 whole square minus 1 is divided by n plus 1 into c. So, therefore, we have to write, you have to expand this one. How you have to expand? N square plus 2n plus 1 minus 1 is divided by n plus 1 into c. Plus 1 minus 1 get cancelled. Therefore, v is equal to, you have to take square root of n into n plus 2 is divided by n plus 1 into c. This is the velocity when the kinetic energy is equal to the n times of the rest mass energy. Square root of n into n plus 2 is divided by n plus 1 into c is there. So, like this you have to solve. It is very simple once you know the thing. If the total energy of the particle is n times of the rest mass energy, then what is the momentum you have to calculate? If the total energy of the particle is equivalent to the n times of the rest mass energy, n into E naught. Total energy of the particle is equivalent to n times of the rest mass energy, then you have to calculate, what you have to calculate? What is its momentum? So, there is a relation between the total energy and the momentum. What is the relation? So, E square, first you have to take the squares on both sides. E square is equal to n square into E naught square. E square is equal to p square c square plus m naught square c power 4, which is equal to n square into E naught square. But what you know? You want to calculate, which one we have to calculate? P you have to calculate. P square c square is equal to n square E naught square, so plus minus m naught square c power 4. So, which one we have to write here? N square E naught square is equal to m naught square c power 4 minus m naught square c power 4. You have to take the common m naught square c power 4, which is equal to n square minus 1, which is equal to right hand side you have to write here p square. So this is the p square value, p square c square. So p square c square is equal to c square, 1 c square get cancelled. Therefore p is equal to, which one we have to write? Once you have to see, p is equal to m naught square c square, m naught square c square into n square minus 1. Therefore p is equal to what we have to write here? Once you have to see, m naught c into square root of n square minus 1. This is the momentum when the total energy is equivalent to the n times of the rest mass energy. Like this we have to write. So whatever the question they given, you have to do based on the problem. It is very simple only. Now one more question you have to take: at what momentum the kinetic energy is n times of the rest mass energy. Suppose you have to take the kinetic energy only n times of the rest mass energy, n into m naught c square. This data they are given. So what they are asking? What momentum they are asking? Momentum they want to ask. Clear? Once again you have to see. Now the total energy is equal to, which one we have to write? Kinetic energy plus total energy is equal to kinetic energy plus rest mass energy m naught c square. Rest mass energy, total energy is equal to kinetic energy plus m naught c square is there. Clear? So now you have to take so which one we have to substitute? Once you have to see, total energy is equal to kinetic energy plus m naught c square. In this equation you have to substitute the total energy is equal to kinetic energy plus m naught c square. You have to take that value, total energy plus m naught c square is equal to kinetic energy. Total energy is equal to, kinetic energy means n into m naught c square plus m naught c square, n into m naught c square plus m naught c square it will come. So therefore what they want to ask, once you have to see, total energy square we want to take, no, n plus 1 into m naught c square. Here you have to take it as a square root of p square c square plus m naught square c power 4. You have to make it on square on both sides. So what will happen? P square c square plus m naught square c power 4 is equal to n plus 1 whole square into m naught square c power 4 is there. Now you have to take p square c square is equal to n plus m naught square c power 4. You have to take the common, n plus 1 whole square minus 1 is there. N plus 1 whole square minus 1. 1 c square we have to get. P square is equal to m naught square c square into n plus 1 whole square minus 1 is equal to n into n plus 2. So therefore P is equal to m naught c into square root of n into n plus 2. Like this you have to solve. This is very important. Wherever you go, so you have to do the experiments like this only. You have to do the problems like this only. It is very simple. You come to know what we have to find out, what data they given. So once you know, half of the problem is solved. Later we have to follow the procedure only. Now you have to see how much electrical energy could theoretically be obtained by annihilation of 1 gram matter. This is very important. So many times your competitive people are asking this question in JL, TSPSC, in Polytechnic and DL examination also they are asking this question. How much electrical energy could theoretically be obtained by annihilation of 1 gram of matter? 1 gram of matter you have to annihilate. What will happen? What is the energy can, that is the E is equal to mc square formula only. You have to take E is equal to mc square. M is equal to, what is that mass? 1 gram energy is there. All these things is easiest unit. C is equal to light velocity 3 into 10 to the power of 10 meter centimeter per second. So light velocity you substitute, so E is equal to 1 into 3 into 10 to the power of 10. So whole square is there. Therefore, you have to get 9 into 10 to the power of 20. Which one we have to get? This energy we call it as a ergs. This energy we are going to take it as a hertz. So hertz is a CGS unit. If you want to take into the MKS unit, 1 electron volt is equal to 1.602 into 10 to the power of minus 2 eggs, right. So therefore 1 egg is equal to, so 1 electron volt is divided by 1.602 into 10 to the power of minus 12. So therefore energy is equal to 9 into 10 to the power of 20 is divided by 1.602 into 10 to the power of minus 12 electron volt. Which one you have to take? Electron volt. Now you have to simplify. E is equal to how much you are getting? 5.618. 5.618 into 10 to the power of 32 electron volt. Electron volt is a smallest unit for the energy. Like this we have to solve in our competitive examination. Based on the units also you able to know how we have to find out the question. Now you have to see, deduce the rest energy of an electron in joules and electron volt. Rest energy of the electron, it is also very important. So many times your competitive people are asking based on this question. Deduce the rest energy of an electron in joules and electron volt. What is the rest energy principle? E naught is equal to m naught c square. E naught is equal to m naught c square. Deduce the rest energy of the electron. Electron, you have to take. So what is that electron? The mass of the electron is equal to 9.1 into 10 to the power of minus 31 kg. 9.1 into 10 to the power of minus 31 kg. C is the light velocity. C is equal to 3 into 10 to the power of 8 meter per second. Now you substitute. First you have to substitute 9.1 into 10 to the power of minus 31 into 3 into 10 to the power of 8 whole square. Now you simplify, you will get in terms of the joules you have to get. What is that? 8.19 into 10 to the power of minus 14 you are getting. If you have to simplify, 8.19 into 10 to the power of minus 14 joules, because we substituted all in MKS unit. So the energy of the MKS unit is joule. So not only that, so in joules and electron volts also they are asking. 1 electron volt is equal to 1.602 into 10 to the power of minus 19 joules. So therefore 1 joule is equal to 1 electron volt is divided by 1.602 into 10 to the power of minus 19 electron volt. Already I wrote so in the numerator. Therefore the energy in terms of, so the rest energy in terms of the electron volts, 8.19 into 10 to the power of minus 14 is divided by 1.602 into 10 to the power of minus 19 electron volt. If you have to simplify, you will get how much you are getting? 0.51 mega electron volt you are getting. This is the rest energy in terms of the electron volt. Very important. So many times, so many competitive exams, maybe in your so MSc entrance examination, if you are taking any competitive exam, they will ask electron rest mass energy is equal to 0.51 mega electron volt. In pair production in nuclear physics also this one you will get it. Clear? So this is very important thing you have to see. One more question also I have to teach to you. Today I am teaching 7 questions. I am teaching. Once you have to see what is the velocity of the relativistic particle. What is the velocity of the relativistic particle they are asking. What they are asking, V is equal to how much for a relativistic particle. So you know the momentum P is equal to m into V. but m is equal to m naught is divided by square root of 1 minus v square by c square into v, which is equal to p is equal. So therefore what we have to write here, once you have to see p square is equal to you have to take p square is equal into 1 minus v square by c square is equal to m naught into v, m naught square into v square, m naught square into v square. So therefore p square minus p square v square is divided by c square is equal to m naught square v square. What we want to get? V we want to get. So therefore p square is equal to m naught square v square, m naught square v square plus p square v square is divided by c square. P square v square is divided by c square. You have to take the v square common. M naught square plus p square, m naught square plus p square is divided by, which one we have to get here? C square into c square also you have to get here. So now you have to see v square is equal to you cross multiply p square c square is divided by m naught square c square plus p square, m naught square c square plus p square is there. Therefore v is equal to pc is divided by square root of p square plus m naught square c square. This is the velocity of a relativistic particle. What is the velocity of the relativistic particle? The velocity of the relativistic particle is, this is the relation between whom? Relation between velocity and whom? Velocity and momentum. The relation between velocity and momentum, this is very very important. Like these questions we will get in our competitive exam. So many questions I will give in our app, over purchased our app, they will get the benefit. So please you have to concentrate and practice and get success in your competitive exam. Today is enough. Tomorrow we have to see invariant terms, space like, time like, invariant terms we have to see, intervals we have to see, those intervals, how invariant intervals is existing, those intervals we will be able to see. Thank you so much.